Good day, folks. Let's look at the forces at equilibrium. Now, it's very important to understand what does equilibrium mean. Object is in equilibrium if it's at rest, which means it's not moving. We call that it's a static equilibrium, right? When an object is not moving, it's at equilibrium, but that type of equilibrium, we call it's a static equilibrium. The word static means not moving as well. Object is at equilibrium if it moves at constant velocity. If the velocity does not change, it's constant. Therefore, we call that it's a dynamic equilibrium. It's a dynamic equilibrium. Then, in both scenarios, when it's at rest and when it's not moving, there's no acceleration, no resultant all the time. When an object is at rest or not moving, no acceleration, no net force or resultant force. Let's look at the examples. Here's this box is pushed by two forces, by two people. So the box, let's say it's not moving. Not moving. So if this box is not moving, that means the forces that are acting on it are what? Are balanced. Now, what are the forces that are acting on this? Let's draw. Okay, let me, before that, the forces that are acting here is the normal force and the gravitational force. The gravitational force and the force, the two forces combined, their forces combined, I'll say it's the force applied. It's combined, they're going in the same direction, it's going to be 100 newtons. And then there's a force there which is the static friction because it's not moving. The static friction, it's not moving. So when you draw a vector diagram of that, okay, let me put it this way. These two forces that are horizontal, they are equal but in opposite direction, so they cancel each other. This simply means that even this frictional force is going to be 100 but in the negative direction. Whatever the normal force is, it's going to be equal to the gravitational force. So in this case, the forces are balanced, they cancel each other, so the net force is going to be 0. That means the normal force is equal to the gravitational force, and then and what else? The force applied is equal to the static frictional force. So these forces are balanced. So you can draw a vector diagram that shows that these forces are balanced. You're going to have, okay, let me draw it a little bit down. You're going to have the normal force. The normal force, guys, is the force that the surface acts on an object perpendicular to the surface, and we have the Fs, and then we have the gravitational force that is going down, and then we have the Fs is not going in that direction. This is the force applied. This is the force applied. Force applied, and then we have Fs there. Do you see this diagram is what is closed? It means that the F net here is equal to 0 because that object is not going to move. Acceleration is 0. Even here, let's look at the scenario of the book. This book, it's at rest. Once it's at rest, that means it's at equilibrium. So these two forces, the normal force, are equal. Normal force and the gravitational force are equal, so it's balanced. Let's see this example. We have a plane. This is an aeroplane. This aeroplane, it has the forces that are balanced there. We have a force that lifts up. It's a lifting force. It's a force that lifts up an aeroplane, and the gravitational force are equal, and it's moving in this direction at constant velocity. Let's say it's moving at constant velocity, this aeroplane, so it's moving in this direction. So we have a force applied, which is the force of an engine. We'll say it's Fe, and then we have the weight there, and then we have a force that lifts an aeroplane, it's lifting force, and then we have an air resistance there. So those forces are balanced, guys. What do we mean? the air resistance and the force of an engine are equal but in opposite direction. The airlift and the gravitational force are equal. Don't confuse that and say it's a normal force. There's no normal force because this is moving. It's in the air and it's not on top of the surface. The only thing that has the normal force is something that is on top of the surface. So let's draw a diagram for these forces. Let's draw the force A, the force of an air, and the gravitational force that is going downwards. It's Fg, and then we have the force of an engine, and then we have the force of what? Of lift. The force of lift. So it's a force of lift. It's a force that lifts that. So even here, guys, the F net is equal to 0 and the acceleration is 0. This is closed. There's no resultant here. Or they following one another. There's no tail of the first vector to the head of the last vector.